Hello everyone, welcome back to chemistry class. In today's revision class, we are going to study about homogeneous and heterogeneous mixture. In the last class, we have talked about pure and impure or substance and mixture. There is one more major difference between pure and impure. Now, pure can be divided into elements and compounds. Let's talk about one of the compound, water. Water is made up of hydrogen and oxygen. Now, hydrogen and oxygen, they are gases, but when they react together, they form water, which is in liquid state. And this water has entirely different property than their constituent, that is hydrogen and oxygen. And this is the case with pure. But in the case of impure, this is entirely different. The constituents, they show their same property. Their property, they remain with their properties. Whereas in the case of pure, the constituents, they lost their property and they show new properties, entirely new properties. Okay. Now coming back to impure, it can be divided into homogeneous and heterogeneous mixtures. Homogeneous mixtures, the particles, they are evenly distributed, and in heterogeneous, they are unevenly distributed. Now in homogeneous comes solution, or you can say true solution, whereas in heterogeneous we have colloids and suspensions. Now let's differentiate between solution, colloids and suspension on basis of these four important parameters. Now one more thing that I want to tell you about solution here is, in solution what we have is solute and solvent. It is made up of solute and solvent. Solvent is one which is present in smaller amount, whereas solute is a one which is present in small amount, and solvent is a one which is present in large amount. Let's say sugar solution. So we have water and sugar. So water is your solvent and sugar is your solute, present in small amount. And by using formula mass of solute divided by mass of solution into 100, you can determine concentration of any solution. Okay. Now coming to particle size. Solution particle size of homogeneous mixtures are less than 1 nanometer. Okay. So it is around 1 nanometer or less than 1 nanometer. Whereas in colloids, particle size, it is between 1 to 1000 nanometer. And in suspensions, particle size is more than 1000 nanometer. Now this is one of the things that gives so many different properties of solution, colloids and suspension. Visibility. Particle size is so small, you cannot see particles here. So no visibility here. Particles you cannot differentiate. Like in salt solution, if it is salt is completely dissolvable in water, you cannot differentiate we cannot see salt particles there. Okay. If it is completely dissolvable, if it is above saturation level, you can easily see it. In case of colloid, visibility is very low. Whereas in case of suspension, visibility is high. That means you can see particles by naked eyes. Example, sand in water, you can easily see sand particles. Or soil in water, you can easily see soil particles. Okay. Now, Tyndall effect. Now, what is Tyndall effect? The scattering of light by particles. Tyndall effect, you can see easily if sunlight between fog, you can see a ray of light. Okay, so that is also Tyndall effect, and that fog is a type of colloid that you can nowadays you can easily see it. Okay, so because here particle size is very small, solution particles do not scatter light, so you will not see any Tyndall effect here by solution. Whereas in case of colloids, yes, they show Tyndall effect, and similarly suspensions, because of high particle size, they also show Tyndall effect. An experiment that I told you earlier also, a laser light, if you pass a laser light through solution, colloid and suspension, you cannot see path of light traveling in solution, but you can see that path of light in colloid and suspension. Now examples of solution: sugar solution, salt solution, lemonade, air, colloid. Now like in solution, what we have is solute and solvent. Similarly, here what we have is dispersing medium and dispersed particles. Okay, we can talk about liquid to liquid, liquid to solid, gas to liquid, different phases. Like if you talk about fog, there you have gas and liquid. When you talk about milk, that is liquid and liquid. Okay, so examples is dispersing medium, which is more and dispersal particles are very small ones. So fog, gel, milk is example of colloid. There are many more given in your book. Suspension, a very common example when you mix soil and water, that is your suspension. Now in case of colloids, when you are mixing the two mediums, the particles, they remain suspended in the medium. They remain dispersed in the medium. Whereas in case of suspension, after some time, the particles, they settle down to the bottom. Okay. So this is what you have for solution, colloids and suspension. And if you have any doubt in this difference between these three, you can contact me. Thank you.